Hey everybody, I want to make a video of a computer science topic because I struggle explaining this a lot of times because Huffman code has been a very complex thing to me, even though I understand that the rule is to convert or compress long text information using a Huffman tree method, and then using the Huffman tree, we will be able to encode it with the bits and binary values that they use. What is complicating with me because it branches out into different ways, keeping in mind that the lowest frequency should be done and combine it with nodes later on. And here's a question that I want to try explaining. And I hope that with this video, if you understand what I've explained, yay, I successfully explained Huffman Tree. If you still don't understand what Huffman Tree really is and how to draw it, then I have to redo this one more time to make it much more simpler. So here goes. Here's a question about the Huffman tree where we need to use we use the sentence called Adam made a mu, and then we're going to create a Huffman tree for this one. So here a table has already been made for us, and that's the frequency there. A has been repeated 5 times in the sentence called Adam made a mu, and D is repeated 2 times in that sentence. Now what I'm going to do is to fill up these things. Okay, the one at the top is called characters, okay? So characters, what are the letters, characters being used in the sentences for this example? And then this frequency will be how many times it has been used inside, frequencies inside right here in the sentence. So here I'm going to start AD has been made for us, and then M is right over here, so I can list it there. And then there is also space there, and in computer science or in computer data, space also means something in there. So we're going to make sure we place SP as space in there, representing space. And then the next thing after space that's not repeating will be E, and then I can just see that L will be the last character or letter used in this instance. Now the next thing we're going to do is to calculate the number of times repeated or frequency that's used for the letter M. So M 1, 2, 3, starting from here, 1, 2, and 3, that will be 3 times. And then we have 3 spaces as well, 1, 2, and 3 spaces there. And then E has 2 repeated frequency, and then L is just right there because E here, L there, so that's 1. Now, we already completed the frequencies table above the sentence, and now we can use this to create a Huffman tree. Now, based on what I understand in the Huffman tree root is, we need to start with the character that has the lowest frequency, and then we start creating nodes to combine them. So at a glance, we know that L right there is the lowest, so I can just go ahead and just write an L there, starting with the lowest on the left. And then I'm going to find the second lowest, which is 2 right now, which is D. So I'm going to put D side by side with L. And what we have to do right now is to create a note, and we are going to add the frequency that they have together. And this would be something like 2 plus 1 is 3. So this will be added up to be 3 instead. All right, let me just erase that. 2 plus 1. When these combine together, it'll be 3 and creates a note for that. So the next thing we're going to do is to find the next lower frequency, and that will be E. So E can be written at the side. And now we're going to use M because there's no more other letters that is under the frequency of 2. So we're now moving up to 3, which is M. So when E and M combines together as a note, they will be then use as 5 right over here. Okay, so we have 2 nodes created already, tree 5, and now we're going to continue using the next node. Now, since this node right over here on the left is lower than 5, so I'm going to create another node here, and I'm going to just put the space SP right over here, and then combine them in a node. So this node will combine space, and then they will be made at a 6 value of node there. and that will be a node for SP when combined. And the next thing we're going to do is using A to combine this one because A right now is the same lower frequency. So we can create a node, which is on the right hand side, and then A just beside this one. And we can then, when this node combine A plus 5 will be 10. And then we can close this node. And since there's no other characters that we could use, we can then close this node to the root cause of the 3, and it will be the 16 value. All right, so that is the Huffman tree. And then the next thing we're going to do is to draw out the binary values of the rule. Based on the rule of Huffman code, nodes on the left is 0 value and the right is 1. So we can do this to this node as well. 0, 1, 0, 1, 0, 1, 0, 1 for this node, 0, 1, 0, 1 for this node as well. All right, so that will be the Huffman tree being created. So there is a question right at the bottom. What is the encode compressed letter for LEAD, which means what is the binary encoding for when this Huffman tree is being created? So let me just write LEAD right over here, and we can then start with one letter. Now L is just right here. I'm going to change a little bit of a color so that we can see here. L is starting from this direction. So L is in this position, so we can start going from the root where here is 0, and then moving towards here, 0 as well, moving towards here. L has the binary encoding of 0, 0, 0. Now, we're going to use another color for E this time, and we're going to find what is the binary encoding value for E. And this time will be 1. And then when it goes to the direction, it will be 0. And goes to this direction, it will be 0. So 1, 0, 0 over here. All right, so next value, I'm going to use another color. This time, let's use purple so that we can distinctly see which direction we could use. So now is A will be in this position 1, and 1 is only 2 binary values for this encoding. And finally, we do have, let's do have another color. This time I'm going to try to use a little bit of a dark blue, perhaps. No, this different color. And then D will be in this direction. So we're going to go here, 0, and then here, 0, and here will be 1. So the final encoding value will be 0, 0, 1. Hope this explains. And if you're doing Huffman Tree, I hope this also helps you a little bit. And if you have never tried Huffman Tree at all and you want to get better on that one, go ahead and ask me along. I'll